Okay, in this lesson I'm going to just look at some questions. The first question from Thursday's class on the 23rd of September. And this first question I'm going to solve in a few different ways, looking at different people's approaches in the class. A few different approaches came up. First of all, we have to know the factor theorem, and it says that x plus a is a factor of f of x if and only if f of negative a is equal to 0. Okay, where f of x is a polynomial function. So that's kind of a hint, I suppose, for the next part. This says f of x is x squared plus 5x plus p, where x is a real number, and p has to be between negative 3 and 8, and p is also an integer. So let's find the value of p, which x plus 3 is a factor of f of x. So we're given that x plus 3 is a factor of f of x. Therefore, well, negative 3 must be a root of the function. F of negative 3 is 0. So what I'm going to do is I'm going to plug in negative 3 into my function here, and f of negative 3 by my rule for my function would be the square of negative 3. Make sure to include brackets, plus 5 times negative 3 plus p. Get rid of this thing. And we know that has to equal to 0. And then we're just solving for p here. So I'm going to get 9 minus 15 plus p is equal to 0. Solving there, p has to equal to 6. So p must be equal to 6. Okay, solving that equation. So that's one approach. That's just one approach, using the factor theorem. Let me look at another approach some other people made. Well, one person I know said, well, if it's a factor, then f of x equals x squared plus 5x plus p must equal to x plus 3 multiplied by some other number. Let's call this x plus. It has to be x, because x by x give me my x squared. On this thing here, let's just call it a for the moment. Some of you will see it straight away. And so one thing, if you know how you multiply binomials, x times a plus 3 times x has to give me 5x, so you might see straight away that a is 2. If you didn't, just multiply out your bracket, x squared plus ax plus 3x plus 3a. Okay? And I'm just going to factor out an x from those middle two terms. So in the middle two terms, we get a plus 3 plus 3a. So what we're going to look at here is if this is equal to this always, well then what we're going to do is we're going to just equate the coefficients of like terms. So 5 would have to be equal to a plus 3, which would mean a would have to equal to 2. Okay, of course we weren't asked to find a, we were asked to find p. So p is the term independent of x there. So p is equal to 3a. And if a is equal to 2, that's 3 times 2, which is 6. Okay, so that's another kind of approach. Another approach, somebody in the class was using synthetic division. So what they said, well, if x plus 3 is a factor of f of x, well then division x squared plus 5x plus p divided by x plus 3 will leave a 0 remainder. We'll leave a remainder of 0. So what they did was they used division. And you can use synthetic division here, since we're dividing by a single x plus 3. It's a linear binomial with a leading coefficient of 1. We put the opposite of plus 3 in the box. We put the coefficients here from the dividend, 1, 5, and p along here. We skip a line, draw a line, bring your 1 down underneath the line, 1. And then it's just a couple of steps. Multiply negative 3 by 1, negative 3. 5 added to negative 3 is 2. Multiply negative 3 by 2, that's negative 6. And that has to be 0 because it's a factor. So if p minus 6 is 0, then p must equal to 6. Okay, so there's 3 different ways to solve that first question that came up.